Hello my dear students, today we are going to discuss about the Laplace transform and a particular method of Laplace transform. So today we will solve a few examples by taking partial fractions. So there are three cases in partial fraction. So first we are going to discuss case 1. So what is case 1? So we have been given some inverse Laplace transform of some function, and you can see in denominator there are three non-repeated linear factors. Our second case will be if denominator has repeated linear factor, and in third case we will discuss if denominator has quadratic factor. Okay, so how to find out the inverse Laplace transform if we have a function and in denominator we have three non-repeated linear factors. Okay, so you know very well about this case because you studied this type of questions of partial fraction in 11th or 12th science. Okay, but still we will revise it. So how to find out? So first we should guess the factors, different factors. For example, let's consider 2s minus 1 divided by s plus 1 s plus 2 s minus 3 is equal to a by first factor plus b by second factor plus c by third factor. As we have three non-repeated linear factors, so we will assume this way. Now simplify this equation. So you can write right hand side part a into s plus 2 s minus 3 plus b s plus 1 s minus 3, and with c you can write s plus 1 s plus 2, right? Okay, and left hand side in numerator part it is 2s minus 1. So we are getting one equation and we are cancelling denominator part because in both sides denominator part is same. So we have this equation. Okay, ultimately we want to find out the particular value of a, b and c. How to get the value of a? So take s is equal to minus 1. When you will take s is equal to minus 1 in this equation, then you will get a. So put different value of s. One time we will take s is equal to minus 1. So how to decide what values will help to find out the a, b, c? Okay, so you can see this factor. For s is equal to minus 1, this factor is 0. For s is equal to minus 2, this term is 0, and for s is equal to 3, this term is 0. So this way you can identify three values of s. So by taking s is equal to minus 1 in this equation, we will get the value of a. How to get? Take s is equal to minus 1 both sides. So left hand side it is minus 3, right hand side a, take s is equal to minus 1, so this term 1 and this is minus 4, and these two terms are 0 because it has s plus 1 factor. Okay, from this we can get value of a. What is the value of a? It is 3 by 4. Similarly, find out value of b or c. When we will take s is equal to minus 2, left hand side part is minus 4, minus 1, minus 5. Right hand side, first term will be 0 because we are putting s is equal to minus 2, and third term is also 0. Minus 1 and here minus 5. So b is equal to minus 5 divided by 5. You can write minus 1. Am I right? Now for s is equal to 3. What is the value of c when we put s is equal to 3? 5, because 6 minus 1 5, and c 4 due to this term 5, and so C is equal to 1 by 4. Clear? Okay. So we are getting different values of A, B and C. Now these both terms are equal. So instead of this, you can write this portion. So ultimately we want to find out the inverse Laplace of this term. So these both are equal and we have guessed A, B, C arbitrary number, but now we have particular value of A, B, C. So instead of this, you can write L inverse A by first factor plus B by second factor and C by third. And we have actual value of A, B, C, where A is 3 by 4, okay, B is minus 1 divided by S plus 2 and C is 1 by 4 divided by S minus 3. Now you know very well what is inverse Laplace of 1 upon S plus 1, where 3 by 4 is constant, and inverse Laplace of 1 upon S plus 1 already we had discussed in previous 3 videos, e raised to minus t minus 1 and e raised to minus 2t, okay, and last one 1 by 4 e raised to 3t, okay. So this is the inverse Laplace of this function. So this is the final answer. Okay, now second case is how to find out the inverse Laplace if we have a repeated linear factor in denominator. So let's assume this given value is equal to A by first factor, B by second factor, where we have two same factors, right? Repeated linear factor. So we will write this way. So sometime there will be 3 repeated linear factor. So how to guess? How to guess this term? So for that you can write plus D by S plus 1 raised to 3. If there are 4 times, then again you can add more terms. Now same method which we had discussed in the case 1. Simplify right hand side term. You can write A S plus 1 square. We are taking LCM. B with S minus 2 and S plus 1 plus C into S minus 2. Okay, and left hand side in numerator it is 1 only. So this equation we are getting. Okay. Now as for the previous case, we will take few values of S to get the values of A, B and C. So how to guess? So here we have two factors, S minus 2 and S plus 1. So simply write down S is equal to 2 and take S is equal to minus 1. But here you can see we have 3 unknowns and we have only 2 different linear factors because this is repeated linear factors. So we will do some assumption for that. So first solve for S2 and S minus 1. So if S is equal to 2, so 1 is equal to A and 3 square because S is equal to 2 and these two terms are 0. So A is 1 by 9. Clear? Now for S is equal to minus 1. This term is 0, second term is also 0. Now we will get value of C. What is C? C is minus 1 by 3. Okay, now how to get B? Value of B is pending. We have 3 unknowns and only 2 different linear factors. So you can take any value of S. So S is equal to 0 is very easy as compared to other value. So we will take S is equal to 0. So take S is equal to 0. So first term is a. Here, due to this term, take s is equal to 0. It is minus 2b, and this term will be minus 2c. So you can see we are not getting exact value of b, but we get some combination of a, b and c. But already we have value of a and c. So how to get value of b? It is very easy. You can write b in terms of a and c. So what is b? b is 2b is equal to a minus 2c minus 1, where b is equal to 1 by 2 a minus 2c minus 1. 1 by 2, where a is 1 by 9 and c is minus 1 by 3 minus 1. Now simplify this term. Okay. So we'll take LCM. So this value LCM is 9, and this term you can write plus 2 into 3, 6. Okay, minus 9. Clear? So 1 by 2, and this one is minus 2 by 9. So finally it is minus 1 by 9. So now we have values of a, b and c. Now you can substitute these values in this assumption. So now L inverse of this is equal to L inverse of this. L inverse of a by first factor, where a is 1 by 9. 1 by 9 into s minus 2 plus b. b is minus 1 by 9 divided by s plus 1, where c is minus 1 by 3 divided by s plus 1 square. Now one last step, find out the inverse Laplace of this. 1 by 9 e raised to 2t minus 1 by 9 e raised to minus t. And how to find out the inverse Laplace of this term? Think about it. Think about it. Okay, 1 by s plus 1 square. So here we have to use inverse first shifting theorem. Let's guess s plus 1, replace s plus 1 by s. First think about inverse Laplace of 1 by s square only. What is inverse Laplace of 1 by s square? Where n is 1. So t raised to 1 by 1 factorial. Okay. And due to the shifting, you can write e raised to minus t. Okay. This is the inverse Laplace of this question. Okay, now case 3. So what is the difference in this case? So here you can see we have one quadratic factor in denominator. So it has no any real roots. What is the factor of s square plus 1? We know s plus I and s prime minus I, because it has complex root. Okay, so in this case, how to find out the values of a, b and c, or any arbitrary numbers? So how to guess in this case when denominator has non-repeated denominator has quadratic factor? So as per the previous case, here we have one linear factor a upon s minus 2. Now for quadratic factor, you have to write down b s plus c divided by s square plus 1. Okay, so in numerator you have to guess this type of combination. Okay, if it has two quadratic factors, if we have one more quadratic factor s square plus 4, so what we'll do, we will write down here plus ds plus e divided by s square plus 4 simply. Okay, now simplify right hand side part. A into s square plus 1 plus bs plus c s minus 2 a s square plus a ba square minus 2bs minus 2c. Clear? Let me check. bs square minus 2bs, okay, plus cs. Now it's done. And in left hand side, in numerator it is s minus 1, and denominator part will be cancelled out on both sides. So we are getting this equation. So here we are not going to put the values of s, but in this case we have to compare the coefficient on both sides. So we are equating the coefficient on both sides. So what is the coefficient of s square in right hand side? You can write a plus b s square. What is the coefficient of s left hand side? C minus 2b, and constant term a minus 2c. Okay, done. This term with s, c minus 2b, and constant term a minus 2c. Clear? Okay, in left hand side you can write what is the coefficient of s square? 0 plus s minus 1. Now we are equating the coefficient on both sides. So we are getting three equations. Which three equations? A plus b is equal to 0. The coefficient of s now. Sorry, I have to put s here. C minus 2b is equal to 1, and constant term a minus 2c is equal to minus 1, because constant is minus 1 in left hand side. Now we have three equations. Now try to solve these three equations and find out the value of a, b and c by eliminating any variable. So how to eliminate variables? So we have three equations and three variables. So first we will try to remove any one variable. Which variable is more easy, okay, as compared to other? So here I will try to remove b. How to remove b? So multiply equation 1 by 2. So 2a plus 2b is equal to 0. Or simply, instead of this, you can write b is equal to minus a. It is more easy, okay? And substitute the value of b in this. C plus 2a is equal to 0. Clear? Because b is equal to minus a. And this equation is minus 2c plus a is equal to 0. Now from this equation you can get value of c by removing the value of a or c. So again we will multiply first equation by 2. So it becomes 2c plus 4a is equal to 0, or as I told you, you can write c is equal to minus 2a. Second option, c is equal to minus 2a, and substitute this value in this equation. This equation is minus 2a plus minus 2c plus a is equal to 0, where c is equal to minus 2a. So this will become plus 4a plus a is equal to 0. So 5a is equal to 0. I think I did one mistake over here. This is not 0, this is minus 1. Okay. Due to that, I have to write down here minus 1. Okay. And this term will be minus 1. So 5a is equal to minus 1. Now it is okay. Then a is equal to minus 1 by 5. Clear? So we are getting a value of a. Now how to get b? We have relation between a and b by this equation. B is equal to minus a, so you can write 1 by 5. Now what about c? Still we have a relation between a and c. So So c is equal to minus 2a. So it is minus 2 by 5 because a is minus 1 by 5. That is why it is 2 by 5. So we have a, b and c. Now we'll substitute this a, b, c in this assumption. So now this term can be written a by first factor minus 1 by 5 divided by s minus 2 plus b 1 by 5s plus c divided by s square plus 1. Now find out the inverse Laplace of this. Minus 1 by 5 e raised to 2t plus, think about this term and then this term, 1 by 5 cos t plus 2 by 5 constant into 1 by 1 into sin t. So 1 by a sin t is the formula. Okay, here 2 by 5 is constant. This is the answer. Thank you.